And yes, let's start. So welcome to the Digital GEOHack virtual conference organized by EAGE IFP Student Chapter in collaboration with the EAGE Local Chapter Paris. So the topic today will cover the impact of machine learning, new technologies and innovation on the field of geosciences and how they are used to face nowadays industry challenges. So basically me and Fernando Villanueva from Local Chapter of Paris are going to present the speakers and the discussion panel later on. And yeah, let's see, I'm really honored to see so many participants, like almost 100 here, I can see. So yeah, I hope you will enjoy it. Before starting, please find here a few guidelines. So as you probably know, your audio and your video are automatically off, as you can see. And so please keep it like that in order to facilitate the good progress of this event. And if you have any question during the presentation or at the end of it, please write it down in the chat below and we will answer them during the Q&A session at the end. Moreover, the event will be recording and publish it on our social network, so you will find it later on. Here is the agenda of this virtual conference today. So basically, we will have a first presentation about challenges and solution to AI and machine learning application in energy and production decision making from Laurent BUTRE from Schlumberger. And then we will have the presentation by Milena Marjanovic, Digital GEOHack at IPGP, the event and outcomes of the hackathon. And then after that, we will have the pitch of, two from the sorry, I think okay, it's okay now. Yeah, there will be the pitch of two teams that participated in the Digital GEOHack and IPGP last November, and will be the first presentation from Nicolas Shi about log data prediction with machine learning, and then there will be Mathias, MESCHEDE, and Charles Lelos presenting estimating mineral mixture from spectral data. So it will be like a short pitch, a 5-minute pitch. And then after this three main part of the event, there will be a Q&A session at the end and a debate with experts. Basically, the topic will be the companies and digital transformation and how the innovation and new technologies are used to face industry challenges. So yes, we will have this Q&A session just at the end, and we will integrate it with the debate with experts. So basically here I will briefly present the EAGE in case you don't know it. So EAGE is the European Association of Geoscientists and Engineers, founded almost 70 years ago as a global association that connects geoscientists and engineers all around the world, and provide groundbreaking events, top-level publication, and much more. So the common mission is innovation and leading-edge technologies. At the present time, there are more than 19,000 members worldwide involved and interested in several topics like geophysics, geology, reservoir engineering, mining, and so on. So for more information, please do not hesitate to scan the QR code that you can find here below. And just briefly, I would like to present you the EAGE board of IFP Student Chapter, that acting as a link between academics, industry, and students. So the board is composed by the president, it's me, Giuseppe, and then there is Precious, vice president, Corentin, the treasurer, Federica, secretary, and then Dalenda, board manager. And this pie chart represent the different countries of members, highlighting some strong points of our chapter, there are diversity and multiculturalism. I would conclude this introduction, inviting you to participate to the next event organized by IFP School alumni in collaboration with IFP School Alumni Club Russia. And there will be a conference about hydrocarbon, energy and climate, a personal view by Tim Krom from Technip, Norway. And it will be more or less at the end, middle end of June. So the date will be confirmed soon. So stay updated on our social network. And let me conclude saying that we will also represent our student chapter in the EAGE Annual Conference 2020, that this year will be held in Amsterdam next December. So now I would like to thank the local chapter of Paris for this collaboration. And it was very nice to work with you. And during this conference, there will be Fernando Villanueva from local chapter Paris that will moderate the debate with me. Yeah, and Antoine from local chapter as well that will moderate the chat. So please refer to us if you have any question. So please, Fernando, back to you.
Yes, Fernando here. Just to briefly detail what our mission for local chapter Paris. We are a group of people that we want to invite companies and universities from all Paris region to, well, afterwards seminars when we will be open to do it physically. Anyway, we have webinars, we prepare webinars. We had 2 already that have been done. We collaborate with the student chapter to do this. And we want to invite you also to the upcoming webinar that it will come on the 16th June. So please visit our LinkedIn page. You can enroll there. So you can go forward, Giuseppe.
Yes, great. Thank you, Fernando. And now I think it's time from Laurent BUTRE from Schlumberger. So maybe Laurent, could you please share your screen in the meantime?
Yep. Can you stop sharing so I can?
Yeah, in the meantime, I will present you. Basically, Laurent is the director of the Artificial Intelligence Lab at Schlumberger in Paris. It has been a long professional career in Schlumberger, and he defines himself as a geek and a photographer who is still shooting regular films in medium format. He's passionate about solving problems. His motto is make it simple, initiate, propose full impacts. So basically, yeah.
Thank you very much, Giuseppe.
Laurent. Thank you.
So I have about till the top of the hour to entertain you with that presentation. It's going to go quite fast and keep a little bit of energy at the end because that's where I put the nuggets. So I will start by presenting myself a little bit. My name is Laurent BUTRE. I'm working for Schlumberger. And actually today is my 23rd anniversary with Schlumberger. I started in Paris, did most of my career in IT, and recently moved into artificial intelligence. So I studied in Paris, spent 4 years in New York doing support, came back to Paris a few years, went to Australia to take care of Australia, New Zealand, and PNG for 3 years. Then I moved to Houston, Texas for 5 years, where I was in charge of 100,000 plus devices in the world, plus 50,000 mobile devices. Over the last 2 years prior my last assignment in Paris, I spent time in San Francisco doing IT innovation. So these are a couple of pictures of the places I've lived. Then I'm going to go over Schlumberger very, very quickly. You, I'm sure, know the company. We are the world leaders, providers of technologies for reservoir characterization, drilling, production, processing, and for the oil and gas industry. 100,000 employees worldwide, 140 nationalities, 85 countries. I've discovered 3 of them. A lot to do. In terms of France, we have 6 technology centers, 2 training centers, 3 headquarters, and 2 operational bases. This is our footprint for France. You know that. I'm not going to go through the operations and what we do in the business. Just remember the drill bits. I'm going to give an example later on. These are the type of data that we are collecting, seismic and reservoir characterization. I'm not going to get into the business because you know more about that than me. I will go into the AI soon. And the last slide about the industry and where to innovate. This is the different categories where you should put your efforts to bring solutions and to improve what the people in the field is doing. So improvement of operational efficiency, this is the top priority for innovation. Reducing cost, I mean, you know the economy right now. The price of the barrel is not really good. So reducing cost of operation is a mandate that we have to follow or try to improve. Improve access to potential reserves, increase the lifespan of our assets, improving the safety, of course, and for Schlumberger, that's actually the top number one. Critical for competitive advantage, innovation is the key differentiator. Keeping pace with regulatory and so forth. So these are the main topics we are looking at when we do artificial intelligence. Okay, so I've said 4 times artificial intelligence in the presentation. Let's start with a definition, so we are all on the same page. The CNRS was giving a definition that I like, which was the study of computation that makes it possible to perceive the environment, learn from the environment, reason, decide, and the most important, act. If you don't have that last piece, it's not worth actually doing any analysis. So you need that action. Machine learning is the science of studying of algorithm and statistical model. So you need historical data to work on it and predict what's going to happen in that statistical model. AI is a big word, a lot of domains. If I start from the center, you have the big cognitive domains, the machine learning, natural language processing, the knowledge representation and reasoning, the automated planning, the intelligent robots, and the machine perceptions. Think about it as the different tasks that a human can do. If we go into the machine learning, and that's the second half of the presentation, we talk about supervised learning, reinforcement learning, unsupervised learning. And that's where a lot of people put hopes into artificial intelligence. But you also have, within the natural language processing, everything related to speech or text. You have the representation and the reasoning, all the ontology. You have the planning and scheduling, which is a very complex problem. It's actually how Bill Gates started with Microsoft. You have the robotics, anything that is software assistant or physical motions and manipulations. And then what has made the buzz recently, because of the power of calculation that is now available, is the machine perception with the computer vision, the computer audition, and the computer touch, or the machine touch. So these are the domains we are playing with when we do artificial intelligence. I wanted to show you an example of what we do at Schlumberger, for example, with the borehole images. So when we measure the boreholes, electrical, ultrasonic, and other electromagnetic fields, when we unfold that cylinder, we obtain a 2D image. And because the pads don't cover the entire size of the or diameter of the hole, we have missing values. So an example of what we can do with generative adversarial network, neural network, is to actually recompose the image, guess the missing pixels to have a full complete image, which is a representation of what we think should be there. It's not the ground truth, it's an extrapolation. So these are a couple of examples of measurements from the pads and then reconstruction of the missing pixels by neural network. So that is one of the examples that I wanted to bring today. The second example, so I told you, remember the drill bits, and many types of drill bits. One of them, many sizes as well. One of them is the diamond cutters. So we do have a facility that manufacture these little diamond cones. And when they go down the hole to drill, they get damaged. And an engineer in the base that receive a drill bit has a task to actually repurpose the diamonds and assess the wear of these diamonds. It's like a dentist. There is a cheat sheet that they have to tick and say, okay, we need to remove that tooth, and we need to turn that one by 90 degrees, and that one is good and can stay. And it takes forever to actually do that. So what we did is with computer vision, we built an application that would recognize and classify these tooth and the wear of these tooths to say, okay, that one needs to be kept, that one needs to be rotated, and we implemented that onto a mobile device. So when the engineer is at the base, he can actually look at a drill bit and we'll see what are the positions that needs to be maintained and those that can stay as is. So these are a couple of acceleration of the work and optimization of the work that we do with artificial intelligence. And here it observed the environment, it made a decision in terms of the condition, and brought that decision to the eyes of the engineer so they can act on it. So going back to the definition. Okay, so a little bit of an extra. I have a little bit less than 5 minutes, and I told you, keep your energy for that last slide. It is the one. What I would like to explain here is a summary of a course that we do in Schlumberger for our people on how you actually think about AI and how you can project yourself in the solution or formulate your problems so you have a chance to actually solve it by AI. So it's not a magical wand. You really have to go baby steps to do that. But the first thing to think about and to ensure is that you have a clear workflow. You have a digitalization that has been done. You have an automation ready. Then you can put AI. And that works by acting will only happen if you have that automation. Digitalization is a way to actually get your input and observe your environment. And the clear workflow is you need to know what you have to do before you start to automate, before you start to get a decision automatically. Because if you don't, the algorithm will give you an answer and you will not be able to validate it. And you will not be able to trust it. So first thing, the 4 steps, clear workflow, digitalization, automation, then you put the cherry on the cake, the AI. There are 5 stages to do AI. You need to obtain your data, which may come from different sources. You have to scrub it, meaning you have to put the dates on the right format. You need to put the units in the right units that you want at the end. And you have to make sense of the different join that you may do from your data. Once you have that at one place, you need to explore, you need to understand it. And up to there, you haven't yet done data science. You have done data analysis, you have done data engineering, that's the exploring, and this is what the domain expert needs to do. And then once you know what you have in terms of your data, it may be too huge to explore it all the way by a human, that's where computer may help, but you know what you are trying to find. Therefore, you are going to put a model and look at the statistics and then interpret and bubble up a decision. And that is the task of the data scientist. So you have two types of data sets that you can use. You have the structured data and the unstructured data. Typically, a structured data is what you have in a database, but it's a little bit more restricted than that. It's a subset of what you have in a database. It's a database where you have your properties correctly measured into columns, and you have all your inputs as is that you want to interpret. Unstructured data can be video, but it can be a PDF, it can be a document, it can be a time series, it is an image. That is the biggest chunk, basically the hidden side of the iceberg. Then you have two types of outputs for this data. And these are the critical questions that you have to ask yourself when you start an AI problem or machine learning problem. It's either a classification. My pixel belongs to a cat or a dog. And yes, when you do segmentation on an image, you go pixel by pixel. Or it's a regression. And it's like, what is the price of the house, considering that it is in that neighborhood, it has that many rooms, and so forth. And you are looking for a continuous value along a scale. You have two phases for machine learning. You have the first phase, which is the training. It requires often quite a lot of compute power because you go with the historical data. You take your raw data, you have a class, if you are doing a classification, for example, pretty much you have the answer. You try to extract properties. Properties are, if you are looking at an object, it could be the weight, it could be the number of rooms, what makes it remarkable for your data set? What is the particular information that you have in your data set? You extract these properties and you project them into a dimension or multi-dimensions to create clusters. And you try to draw a function that will separate these clusters. And the function is just the evaluation of the properties that you selected. The more properties, the more complex it is to calculate. And that is the trick and the work of the data scientist. The second phase is the inference. You take a new raw data, you look at their properties, so let's say the numbers of rooms of the apartment, the neighborhood maybe, the superficie, and you calculate the function and you say if it's more than a certain number, if it's above that function, then it belongs to that class. You get into some problems of overfitting, underfitting. Where do you draw the line? How do you draw the line? I'm not going to go there. Then you have two types of learning. The supervised, where the human will try to get these classes. You have a data set that has been already labeled by the human. So you try to make these clusters, or it's unsupervised and you don't have the answer and you're trying to see if you have packets of initial data sets that, or initial points that actually separate from each other's. And then you are going to look into one cluster and say, is that representing what I'm trying to guess? And then you have two types of errors, the false positive and the false negative. This is where the domain expert has their word to say. Do you want to be conservative? Do you want to be pushy into your algorithm? This is basically in that curve here, the line, the function, you are pushing it on one side or the other side. So the middle values, the functions that you calculated are pretty close to your junction. You have to make a decision if you want to make it on one side or the other one, making it false or making it true, basically maximizing either the false positive or the false negative. And then you have two types of extractions for the features that you can do, which are either machine learning. The human is trying to find the best properties to model your data set, or you use a lot of compute power and you do deep learning and you try a lot of things, and the machine is going to actually find which properties you want for your data set. And I will stop there in about 15 minutes. That was really crash course. I hope the last nuggets was useful for you. We'll go with questions a little bit later. Two quotes that I really like. You are the average of the 5 people you spend the most time with, from Jim Rohn, sorry. And you are not your resume, you are your work, from Seth. And if you haven't read the 4-Hour Work Week from Tim Ferriss, I strongly suggest. It's a pretty nice book. With that, I'm going to give the floor back to Giuseppe. And thank you very much for listening. And I hope you will have a lot of questions.
Thank you very much, Laurent. It was very interesting. And yeah, I really recommend to the audience to start to write down the question in the chat, and we will read them at the end during the Q&A session and the debate. So now I will let Fernando presenting the next speakers. Yes, please, Fernando, go on.
Yes, so our next speaker will be Milena Marjanovic, who is a researcher at IPGP Paris. She will present us the experience she have organizing the digital GEOHack event happening 2 months ago, or more than 2 months ago, actually. Okay, please, Milena.
Hello, everyone. Thank you for coming to this virtual workshop, and thank you for inviting me to present my experience about organizing digital GEOHack that was held in November 2019. So I will organize this. Oops, I have some problems. Okay. I organized this talk in 3 parts. I will talk about what happened before we organized the actual meeting, during the meeting, and then after. Okay. So the idea actually started about a year ago in the summer 2019, when my colleague John came to my office and asked me to help him about organizing this hackathon event. He came up with the idea, and he was trying to build a team. And as I organized quite a bit of meetings or workshops at IPGP, I was really happy that he came, and I gladly accepted. Foremost because in academia we don't have many opportunities to have this kind of hands-on workshops. Normally the workshops are organized as talks, so people come present their work, but there is no real real workshop. So we started making our to-do list. And the first point on this to-do list was to actually apply for a grant to get the money for organizing the event. As I have been collaborating with the EAGE quite a bit, I actually immediately suggested that we apply for this EAGE PACE event grant support. And for those of you who do not know about EAGE and the opportunities for funding events, there is EAGE website, and you can find different options. One of them is actually to support for organizing events. What you have to do is actually to write a proposal, there is a lot of questions that you have to fill in, and also provide your objectives and what you want to actually achieve with this event. This proposal is then submitted to a committee, and within a week or so you get actually the answer. And in our case it was positive, so we got about 1,500 euros to actually organize this event. So now when we had the money, we wanted to build a team. And I think that this point for organizing event is very important. John and I went very carefully through, and we wanted to invite people. We knew them, so they are friends and colleagues. But we also knew that they can bring the expertise and knowledge that we don't have, and they can also bring different network. They can include their network. So we included Mathias, who is going to talk right after, Fernando, who is also part of EAGE local chapter, and Yao, who is actually a student at IPGP, PhD student. So we wanted to have different generations as well involved. And then it was the time to pick up the date. This is very crucial part, because once when you pick up the date, that's it. You have to move on. You have to continue. The idea was to actually do this event as a 2-day event. So we picked November 15th and 16th, what I want to point out, we picked up Friday and Saturday. So people who are working in industry, for example, can afford the day off from work to actually participate in our event. And then we had to reserve the venue that can actually fit all the requirements for organizing this kind of event. And IPGP, Institut de Physique du Globe de Paris, was a perfect place to do it. So we got the permission to organize it there, and so we could move on. This was the first part. So once we had a date and the funding and everything in order, we continued to work together. So the whole team was building up the program. One important thing, it was also to build the logo. So the logo is shown on here on the right. We started to do our kind of logo design, but at the end it was a professional who did it, and we are very happy because it attracted quite a lot of attention. We advertised the event, and that's where the point of bringing different people within the team is very important, because the event was advertised through different channels, and so we had a really good mix of people coming from a background, from machine learning background, and also geoscience. We invited speakers, then of course that's catering, and we also produced some t-shirts. So at the event itself, so it was a 2-day event, we had this kind of introduction. So the first part, or the morning session, was actually dedicated to introduce the event, and also have some invite speakers, people who will talk about their projects. So we had Martin Renaud, who was talking about Voila project, and Mathias, who was talking about functional programming and reproducibility. It was very nice, not only because they provided a background, or they could introduce the topics, but also because they could break the ice and somehow, and get people to start to talk and to participate, and instead of bringing people and put them straight away to just code. We had 25 participants in the end, so from the beginning till the end. I have to emphasize that we had this kind of organic approach in organizing this hackathon, which means that we let the participants to define their topics, to define their projects, instead of imposing projects that we wanted to work on. In some environments, this is a preferred way of organizing hackathons. In some environments, it's not. So you have to know a bit your audience to actually propose the approach. So the first day was finished with the concert, because that was the event at the IPGP, and it was very nice because participants could stay and get to know each other. Then the day 2, for me, it was the most critical day, or the most critical moment of the hackathon, because I didn't know if the people will show up. You always, it's Saturday morning, and if people didn't like the first day, they will not show up. But luckily, everybody showed up, and we could continue to code. We actually had 25 participants in, they were organized in 4 groups, in 4 teams. the topics of the teams were, so the first group was doing identification or identifying noise signal in seismic signal spectrum. The second group was doing predicting missing parameters from well logs. Then we had a project that was focused on an automatic interpretation of mineral spectrograms, and the fourth one was identifying fault planes in bathymetry data. I have to admit that I was very surprised with the solutions that they came up with. I was hoping, but I was not expecting that we will have really nice results at the end of, to be honest, it was just one day of coding. And you will hear about, if I'm not wrong, you will be hearing about the results of the project, the second from the second group and the third one. And so after the event, it was evaluated as a success. It was a great success, and we were invited to actually write an article for First Break, which is one of the EAGE magazines. We were also invited to give an interview, or for an interview within seismology division of the EAGE, European Geophysical Union, I think. I was also invited to give a talk for a workshop during EAGE annual. That's now postponed because of the virus, but it will be held in December, if I'm not wrong. And we are also thinking about what to do in the future. So there may be more events to come. Actually, one of the participants in one of the teams, I saw her before this lockdown, and she asked me actually when will be the next one, because she has quite a lot of data to work on. I would like to finish this talk with the take-home message. If you would like to organize the meeting, you have to start on time. So we started a bit like maybe 5 to 6 months before the event. There are quite a lot of things that you have to check on your to-do list, but one of the most important is to build a good team. I think that's basically, that was the key for success of the hackathon that we did at IPGP in November. And then of course you have to do a good publicity, so build a program, advertise it in different channels. And for me, it's also a thing that I learned is to actually know your targeted audience, because in that way we could organize our hackathon to be more somehow more free. And one of the comments that we had after the hackathon was that people liked it because it was not, there was no imposed topic. People could do what they liked, and people from machine learning background, they learned something about geoscience, and on the other hand, the professionals from geosciences, they learned quite a bit of machine learning and how they can apply it in their daily work. With this, I would like to thank you, and I would especially like to thank EAGE, in particular Ilaria and Caroline, and EAGE Local Chapter Paris, Institut de Physique du Globe de Paris for providing the venue, and especially communication team and the designer of the logo. So thank you, and I hope you have questions.
Thank you very much, Milena. It was quite interesting to hear from you about the organization of the Digital GeoHack and IPGP. Yes, there are so many questions here in the chat at the present time, so we will read them all at the end. Basically, now in the meantime that the next speakers will share his screen, I would like to say that during this IPGP Digital GeoHack, there were some teams presenting some projects, And today we will have, in this part of the event, we will have 2 teams presenting their project. And the first one will be machine learning, let's say, log data prediction with machine learning. And the speakers will be Nicholas Shi. There is a data scientist at Blue Conduit in Arizona, United States, and he studies geostatistics application in natural resource exploration at Paris Tech in Fontainebleau. So yeah, I participated in this with this team during this experience. It was great for me. So for sure, Nicholas will tell you more about it. And yeah, please, Nicholas, I give you the floor.
Thank you. Hi everyone, I'm Nicholas, and I participated in the Digital GEOHack event last November on a team with Giuseppe and others. We created a statistical model that relates different well data and allows us to fill in missing data. I was joined by Aline, Tanner, Mubin, and Doran. As you can see from the slides, we were a very interdisciplinary team. We had many backgrounds and different experiences. We are all broadly experienced in earth science, which was very useful in understanding the problem and communicating effectively and understanding the motivations behind this model. Mubin and Giuseppe were able to explain many petrophysical concepts to us as we developed the model. Aline and Tanner helped us understand the connection between shear slowness, petrophysics, and inversion, and ultimately the motivation behind developing this model. And Doran explained the basics of handling well data and the Bayesian regression approach that we ended up using as one of our solutions. The problem that we addressed was incomplete or missing well log data, which is a very common problem. I was not aware of it at first. My only experience with well logs was lithofacies classification, which is probably the most basic or well-known application of machine learning to well log data. And I'd only worked on very carefully curated data sets. The challenge we addressed is to use density and compressional velocity data from nearby wells to predict the shear slowness, the question mark in the diagram that you see. This is a supervised regression problem. So we are outputting a real number, and we are using, we are training our model on data that we already have the answer to, essentially. We extracted vertical strips from the Marmousi model to simulate drill holes, so this was synthetic data. And we ended up using 2 very different approaches to fill in the incomplete data. We used first gradient boosted regression trees. The basic regression tree should be familiar from experience with decision trees. It has the familiar branching structure. The intuition is the same. The gradient boosted trees are just a group of trees that is built in a specific way that increases the performance of the algorithm in terms of generalization. Its performance on new or unseen data is better than it would be if it were just a single regression tree. XGBoost is probably the most well-known algorithm of this type, and it has state-of-the-art performance on a variety of tasks, and it is very popular in hackathons and competitions. However, it's limited in explainability. We are never exactly sure how the output is generated or what the regression function looks like. It's a large drawback, and it's an active research area trying to better understand these functions. Also, practically the only way to provide domain knowledge or prior knowledge to this algorithm is via clever selection of features. We know that density and compressional velocity variables are related by a physical law to shear velocity, so we select those variables. We also looked at Bayesian regression. It gave us the ability to bring in prior information in a more explicit way. Our group knew approximately what the relationship should look like, and the Bayesian regression model can accept that guess as a starting point and improve it as it is exposed to more data. Where gradient boosted trees are a black box, more or less, MCMC, Markov chain Monte Carlo estimation, and Bayesian regression also gives us a distribution of values and a credible interval. That is the gray band that you see on the bottom diagram. So we have a distribution of possible values rather than a single value and associated probabilities. The results were encouraging as a proof of concept, and we've continued to do work on this project. I think it's related to Aline's thesis. So in conclusion, I just wanted to say that it's very important to have these kinds of exchanges. Technical people can learn from subject matter experts what tools are useful and how they will be used. We can also learn what is reasonable, not only what modeling problems are reasonable. Again, there's a physical law connecting shear and density and compressive velocities. So we are confident that we are not modeling artifacts or spurious correlations, but also what results are reasonable. We benefit from expert interpretation and checking of the model results. We usually don't get this when we're working in isolation. For the more technical people on the team, we can share what is possible and also what is not possible and how to format the data and engineer the model. And sometimes it is difficult to articulate or delineate what is trivially easy and what is almost impossible to accomplish with machine learning. So it is very useful to understand the problems and generate feasible solutions. This kind of format is very good for exchanging these kinds of ideas. So that is all. Thank you.
Thank you very much, Nicholas. Thanks for sharing with us the project we did during the Digital GeoHack. It was quite inspiring for me. And in the meantime, that the next speakers will share his screen. Yes, I will let Fernando introducing the next speakers. They will be presenting estimating mineral mixture from spectral data. So Fernando.
Yes, so our next speakers, we have two speakers that participated in the Digital GeoHack. Mathias MESCHEDE, that now he's working in Twin.io as a data scientist. Charles Lelosque, who is a researcher in Institut Physique du Globe de Paris. Please, you can go forward, Tim.
Yeah, hey. Yeah, so we're giving this presentation with together, Charles and I think it's a good representation of the hackathon, the spirit of this hackathon. So I did my thesis at IPGP in geophysics, and now I'm working in a complete in a company which is fully concentrated on developing software and handling large software systems. And Charles is a researcher at IPGP in geosciences, and so we could bring together a little bit these two perspectives. And so I'll hand off a little bit to Charles, who can explain how we ended up working on this specific project.
My turn will be better. So we were a team of 5 people. Alexis, Lucille, Mathias, Emily, and I, with very different background, mostly seismology, I think. And myself, I'm a geochemist, so working on really different things like volcanoes, magmas, and magmatic petrology. So the first thing we wanted to present is where actually this project came from, what was the start of the project. So during the GeoHack, one condition also to have a successful, I think, GeoHack hackathon is to have projects. And I had a project in my bag, if I can say that, which consisted in recognition of spectroscopic data. And it's really interesting because you can transpose that to many different fields, like you have seismic signal, which are basically signals. And in my field, we have different Raman infrared spectroscopy signals. And then the goal is to classify those signals. Maybe also we can even perform regression tasks, but basically to say what is the origin of the signal. Is it a particular seismic location or a particular mineral for Raman signals? So that was the origin of this project. So in our case, well, basically, we have rocks and they are constituted of minerals and sometimes glasses. And those present very unique spectral signatures if you analyze them with some tools like Raman spectroscopy. So this is one tool which allows you basically to recognize a mineral which has a unique signature. And if you analyze a few minerals, you can estimate the composition of the rock, its mineral assemblage. So it's a very trendy thing to do. Like for instance, the Mars 2020 rover is equipped with a Raman spectrometer in his Sherlock sensor that you can see on this picture. To perform automatic, collection of spectra and recognition of is it organic matter, is it a mineral. But the thing is that there is no existing tool that automatically recognizes minerals from Raman spectra. We have databases which actually exist. We also have open source libraries for treatment of the spectra in different languages like RamPy in Python, ChemoSpect in R, or Spectra in Julia. But for recognition, most software which exist are actually closed source softwares tied to some kind of specific ecosystem software, etc. So for the hackathon, we had 3 questions, I will say. First, how can we develop an open source software to do that? And which algorithm will allow us to identify minerals and also mixture of minerals? And can we trust the estimates? So for working during the hackathon, we had like spectra from one database from 27 minerals, and basically the inputs were the spectra and outputs were the labels. Is it an albite, a quartz mineral, or something else? So those are the spectra. You see 5 spectra from different minerals: calcite, augite, anorthite, etc. So those are kind of clean spectra, like single end-member spectra. But in reality, when we analyze a rock, we also often have mixtures. So that was another problem we had to try to solve during the hackathon. So some kind of real messy data from real rocks. And we tested, as we were a really diverse team, we tested different approaches, like really different things: Markov chain Monte Carlo, random forest, even some kind of iterative subtraction, and also more complex, not really complex, but maybe more fancy stuff like 1D convolutional neural networks. And some of them worked out of the box, like the 1D ConvNet is actually quite good at performing such tasks. We get like a 90% prediction rate in kind of good predictions. And some other tools we still have to, I think, to dig in a bit more in the technique to try it. But that was really interesting to have those kind of diverse, approaches. Sorry. And I will let it there. Maybe if Mathias wants to say a last word.
Thanks.
Okay. Thank you. And yeah, feel free to have any question.
Yes, thank you very much, Mathias and Charles. It was a great presentation. And of course, if the audience, they will have some question about this presentation from the pitch from the Digital GeoHack, they can just write the question in the chat and we will answer them. So basically now the first part of this event is finished. So now let's move to the Q&A session and the debate with experts. So basically, first of all, I would like to, tell you that the discussion panel will be composed by Laurent, BUTRE, Milena, Marjanovic, Mathias, MESCHEDE, that we already presented before. And then we will have also other participants to this discussion panel. There are Antoine, BOUZIAT, I think is the pronunciation. I hope I did it correctly. Antoine BOUZIAT, there is an R&D geoscientist and project leader in digital transformation division at IFP Energy Nouvelle, geoscience division. And also we have Gijs van den Doel, is a freelance international consultant in natural catastrophe modeling with extensive experience in geographical information science, GIS, research, consulting, and advisory work. So we will have this discussion panel, but before starting the debate, we will move to the Q&A session. And I've seen that there are so many questions, and also a lot of participants. We are more than 100 here. So in the meantime, that maybe Federica from the EAGE student chapter will share her screen. We can start with the Q&A session. So basically, yes, we just notated all the questions here. There are so many questions. And the first question, yes, is here. So of course, in the meantime that we will answer to the question, please continue to write in the chat here the question that you may have. And basically, I would like to tell you that the debate that will be after the Q&A session has been envisioned as a spontaneous discussion among experts from different companies and for answer to some questions that the audience may have about this topic. So yeah, feel free to ask any question. And the first question that we have is, what are the problems that are most resolved with using machine learning in the oil and gas industry by Yakan? So I think it was at the beginning, right? So maybe Laurent?
That's a tough question. What we are building in the Artificial Intelligence Lab in Paris, and we do have a team in Houston, we do have a team in India, we do have a team in California. The competencies and the projects we are working on are mainly around vision, time series, and natural language processing. The natural language processing is trying to make sense of all the documentations, all the unstructured data that we have in our servers. So that's a part on the NLP vision. Vision, we do measurements, ultrasonic, electromagnetic, and others from our tools. So it's trying to assess and augment and accelerate the work of the geophysicists that are working from these data sets. I can't give specific details. I don't have the broad vision to say that example is the biggest one. It's trying to solve problems, again, observing the environment, making sense of it, deciding, and then acting.
Okay, great. And I mean, I'm reading
Not
now.
great because I didn't answer the end question, but
sorry,
I didn't really answer the question. It's a tough one.
I mean, I'm reading now the question for Laurent, and basically Vladimir asked, what kind of work are in Schlumberger involved regarding reinforcement? Could you share an example?
Yeah, so we have a product called Drill Plan. Anything that is working around planification of operation is a prime subject for reinforcement learning. Trying to discover your path and what is the most optimum chain of event that you want to do on a rig. Same thing for manufacturing.
Okay. Also, Antoine is asking, can we have a bit more details on automated planning? Is it something Schlumberger work on? What is the main application domain?
I just answered that one. It's a drill plan.
You answered in the chat, right?
Yeah, and that was my previous answer as well.
Also, the next one. There was another question from Lobel saying, what specifically would you suggest to a petroleum engineer to take notice when considering AI machine learning? I mean, what should petroleum engineer know from AI basics deeper pool of knowledge in order to know what to utilize in projects when talking with an AI expert?
Okay, so I can bounce on that one and relate to the hackathon. I can give an example of myself when I was trying and starting to do machine learning. reading and going onto Coursera's and EDX. You have great courses that will teach you the basics. You have platforms like Azure ML Studio where you can play. You have the Google AutoML as well that that can give you spaces where you don't need that much code to try to do something. And I took a problem. It was classification of text. About 14 classes that I wanted to play with and discriminate. On that case, a lot of data. I had 1 million samples, and I reached about 75% accuracy. It was great because it's better than flipping a coin, but it was not that good to go into production. And by already exploring the data, knowing what I wanted to actually do, when I went and talked to the data scientists, we turned the problem in 1 week into a production system that was used in real life because the data scientists told me, oh, you have to separate the languages. You have Russian, you have English, you have French, you have Spanish. You can't learn in one block in all these languages. You need to specify and really specialize each machine learning model per languages. We did that, we gain about 10 points. And then they play on the script and they play on the optimization, and we reached 96%. Then we finally played with the false positive and false negative. In 1 week, it was in production. So if you want to learn, if you want to start, the best thing is to understand the principles, play with a couple of platforms that will let you do minimum coding and clean up your project. Once you are there, go and talk to a mathematician, go and talk to a data scientist, and it will speed up towards the production.
Yeah, if I may, I think it's a very important message, and I fully agree with this. The main skill is definitely not coding. Actually, the technology itself is very well democratized now. You have very high-level packages, coding packages, which are open source. So the main challenge and what is fun actually, it's not really inventing new coding bricks. It's much more adapting the reference ones in a smart ways to fit some business needs and trying to properly select the appropriate training data, adapting the workflows, tuning things to really fit what you want to achieve in a subject matter vision. So it's someone starting on machine learning shouldn't be afraid of not being a coding expert. It's definitely not what is needed. It's more having a clear use cases in your mind and being ready to have the hands-on and take things which have been already coded and adapting them in smart ways to match your objectives. So it's really more democratized than we can think initially if we are not in the topic.
I totally agree with you, Antoine. And to answer Anne Chang's question, which is 3 or 4 questions down about correcting labels with unsupervised and then learning, the one advice that I can give is if you have crap in, you will have crap out. Cleaning up data, quality of your label is key in that domain. And it's 80% of the time of the data scientist to clean up, correctly label, and prune the data sets. It's better sometimes to have less data, but better quality than more, and with missing values or crappy things. That's to try to answer the other question about the size of the data set. In the oil and gas, especially because data belongs to the customer and we are a service company, we don't have the rights to play with all the data sets that we measure. We sometimes start with very little data. Building from little data is a skill that is really important. It's quite tough, but it's doable. There was one mention about synthetic data. I don't really like it because models working on synthetic data works great in simulation, works great in the lab. You bring them on the field, they don't work unless you apply certain tricks.
Yeah, actually, there are some people saying that in oil and gas we don't do big data, but we do smart data.
Yep.
That means that we have less data than many other fields, but there is huge challenges in using them smartly and tuning the algorithms to actually match our objectives with that little data. So it's a new trend. There was this big data buzz maybe a decade ago, and now the big trend in the industry it's more about smart data actually, which is the new keyword.
And the other false idea that we need to destroy right now is that when you build a model, it's pretty much unique for your problem, for your business case. Transferring a model, transferring a workflow from one use case to another one, it could be even from one field to another field, doesn't work. It's really tough. So when the manager comes and say, hey, I want something that will work everywhere, run away.
Yeah. There's nothing working off the shelf on geoscience data. That wouldn't be fun anyway.
I kind of disagree there. You can use certain parts of it, but you have to break it down. And you have to sit down and look back and ask yourself, what is the question that I want to have answered? And then take the best parts out of your previous model and reassemble.
You could, but if you, for example, if I take a time series from a certain measurement, let's say electromagnetic, I will have a lot of difficulty to actually take that model and use it on ultrasonic, even if the workflows are similar. If I have two images that are not looking the same, my model is going to be fooled on the other one. In some cases, I agree with you. If you manage to stay in certain areas that are similar enough, yeah, you can take some pieces. We have so what we call is technology blocks. We had put a couple of patents on technology blocks that we managed to move from one project to 3 or 4 others. But it's just a technology block. It's a way we do it.
Exactly. No, I'm saying the method. I'm not saying the model.
Okay.
You can,
I agree with the method. Yes. Yeah. You of course you learn from one project to the other. You have your certain workflow, and that makes a difference. Pretty much all the time you start from a new data set.
Yeah, no, the data set is problem dependent. You can't say I have a training set or I have a model trained. For me, a model is the methodology that you used. That is for me the model, and that model can be transferred from one place to another place. But you have to retrain, and you have to kind of see where can I optimize my new model.
On the term model, I would maybe disagree a little bit because for me the train model is the weights that you get. But no, I agree on you on the workflow.
Or let's put it this way: the architecture.
Yes.
So the architecture is transferable from one project to another project.
Yes, I agree.
You even have this technique, this subset of machine learning called transfer learning, where you use already trained neural network on a specific data set, and then you keep the whole architecture, but you retrain it only the most shallow layers to use for another domain. But the data that you will pick to do this retraining for the transfer learning will have to be very well selected to match your specific objective or not another one.
Thank you very much. As I said before, we will merge either the Q&A session with the debate. So for all the panelists, please feel free to add any info or your experience about that. And I would like to move to the next question that is for Milena. I would like, Vladimir is asking what programming languages were used during the hackathon, and how many teams took part in it?
There were 4 teams, 4 different topics. I don't know exactly how many people were in each team. Let's say 25 by 4, so it's 6 to 7. Yeah, so we'll let them to organize themselves as they wanted. So basically, people started to mingle during lunchtime, and then they basically presented the ideas. As Pierre was saying, it's very important to have a good project for a successful hackathon, and people came up with very nice projects, nice topics that actually led to great results. And for regarding the programs, maybe the participants can answer that.
So yes, Mathias, maybe you can answer us.
Yeah, so I think we don't know, because every team was on their own, as we said before. But then I think most of them were kind of standard Python solutions, and then we even had this integration with the Jupyter notebooks, where we had the talk of one of the developers of Voila. And I mean, but then everyone added, you know, their own slightly more exotic solution that he knew to the project. So for example, Doran and I from Tweak, we use this thing called Nix to set up development environments. So I think that appeared a little bit, and then yeah, it's difficult to, I simply cannot say what everyone used. So the goal was to get a result, not to.
Yeah, there are people who are using Python. I think that one of the groups was using Python, and yeah, it's. I think that they were using also a combination of different programs.
So one thing which might be interesting is that, so there are quite a lot of tools out there. So if you set up these neural networks with one of the big auto differentiation frameworks, for example, you have TensorFlow and PyTorch. Both of them were used. Then I know for the Bayesian methods we use PyMC3, which is the Python, like a relatively straightforward Python framework to do this. I don't know if there were, yeah, definitely there was scikit-learn, pandas, and so on. So there were all of these different Python frameworks in there, and I think that was the dominating language. I don't know if there was anything completely different in one team, but I didn't see it.
Okay, great. Also, there are 2 questions that are open for everybody. Like one from Olesgun is asking, he is a geoscientist with knowledge in seismic interpretation, petrophysics, and static modeling for reservoir characterization. So I have been looking for a way to link AI to reservoir characterization. What is the first step towards achieving that, being a novice of AI? And the next one that will be addressed to everybody is how you will see oil industry in the next 10 years in AI viewpoint. So yes, I don't know which one of you like to answer.
Maybe on the first question, I can share a personal path. Actually, I started doing reservoir characterization, and I started my career in a seismic reservoir characterization team in CGG before joining IFP. And actually, we were doing a lot of things that we will call now machine learning or artificial intelligence. But at that time, we were calling it geostatistics. And the geostatistical field, actually, it's has a long history behind it. And I don't know how to say it. I think it paved the way for AE, for reservoir characterization, and what we call AE now. So I guess my advice would be first to build a strong knowledge in geostatistics and the classical geostatistical method. And from this experience, then add the new AE trend on top of it. But some books of geostatistics is probably a good start to explore machine learning for reservoir characterization.
Okay. Great. So for the next one, I would like to ask to Gijs, Antoine, and Laurent, what is the preferred programming languages in industry?
At IFP, it's definitely Python, which is the most used by the data scientist.
Or R.
Yeah, I would say Python and then libraries, PyTorch, Keras, TensorFlow, scikit-learn, and so forth.
Okay. Now we have a question, I think, for Laurent. My question is, how many data we need to can do AI, for example, in well logs? How many data we need to be able to perform AI, for example, in well logs?
To bounce on Antoine, big data, but we often have very little. It's a tough question. We sometimes try to start with one well, and we augment the data. If we have synthetic, we may try to put some synthetic, but as I said, I don't really like that. When you talk to a data scientist, they say, oh, I need, I don't know, 500 to 1,000 wells to be able to make the machine learning. When you look at what you actually have, it may be 5 wells. So you do with what you have. And then it's being innovative in the way you treat the data. Right? There is no universal answer with that. Mathias, can you help me, or Antoine?
I think the question is not really how much. It would be more how representative the data I have is from the data I want to analyze the process. So I think the focus shouldn't be always on how big is the data, but more on how representative is my data set from what I want to do.
So I would like to fall back a little bit on what Antoine and Laurent have said before. Especially if you have pre-trained networks, then you can reduce the data that you need, for example, to analyze a new well. Now I'm talking out of my domain a little bit, but I guess you can reduce it quite a lot. And so if you can reuse these models and experiences from other places and so on, you can reduce the data that you actually need in the end. So I think it really depends on this quite a lot. I don't know.
It also depends on the problem you want to solve and how much detail you would like to have in your answer. So it really is case dependent, I think. You can start with minimal data and see if you can answer your question, and if you're not answering your question, then search for more data.
Yeah. The other approach that I like to take as well is when you look at a human task, let's say it's a repetitive thing, it's quite time consuming. What you may be able to do is, for a large portion of that job, have a model that says, in these cases, I'm pretty sure the answer is that. And here's the decision that I want to take from it. And then for these maybe 20 or 30%, the model is not going to work. And if you manage to build automatic QC with your model and know that your confidence is not good in these specific cases, then let the human do it. At the end, what happened is that instead of spending 100% to solve your problem, or 100% of your time, you may just have to concentrate on 30% or 20% of the volume, which may become manageable for a human, and your decision will be better than the model. So ML and AI can be seen as it's not going to get the answer for everything, but where it's sure, it will save you time.
And I think it also depends on your domain expert. How is he happy with the answer, or does he say I need more information, or can you improve the model because I'm not answering the question? Going back to my previous point.
Yeah, and to answer one of the questions about what should I learn or I want to get into machine learning, I think finding the right business case and aligning with the domain expert is really important. I like to cut the space in 4 quadrants. What you know, what you don't know, what is simple and what is complex. Most managers will go into, I don't know, it's complex, AI will solve it for me. It's never going to happen and they are going to be frustrated. But if you play into the I know, and it's fairly simple, you can actually validate what the answer the machine learning is going to give you, then you can trust your model and you can explain it. At that point, you accept it. If you get into a field where 2 domain experts are not in agreement on the answer, it's going to be very difficult to bring a machine learning model and tell them, hey, that's the answer that you need to trust.
Great. Yes. For the next question, yeah, I would like to read the question of Lucia Levato. It was quite interesting. Who can share examples of hackathons to kickstart innovating R&D projects in the industry? So maybe for that we can start from Mathias and Gijs then, because they participated to the hackathon and IPGP. So maybe they can share some example of hackathon to kickstart innovating R&D projects. So what's your example about that?
So in my case, this was the first hackathon that I did. So
Okay.
Gijs, I don't know, you did a few more, I think.
I participated in two others recently or before this one. And there are not really papers coming out, but it is more that people are when I keep in touch with the other participants is that they are reinforced in the methods that they are developing, and that will then eventually come into scientific publications. Or one example is not in oil and gas, that's in insurance, is an hackathon which was dealing with flooding and how to measure the flood, and they developed a method where they are actually with a video camera looking at the water levels and then predicting how much the water will rise, and that actually spinned off into production. So there is chance, and it depends on your contacts, but mainly the benefit of hackathons is enforcing your own thinking and having peer reviews.
Okay. Yes. The next question is just for Laurent, since he's asking which software are often used in machine learning at Schlumberger. It's a very specific question.
We already answered that question.
Yeah, I think so. And then what is the recommendation for getting new skills about AI and machine learning, like learn new programming languages? I think it's also something said before. I would like to ask, is it common to correct the labels using unsupervised learning first and then apply supervising learning on the modified labels Y and then in data X?
So I kind of little bit the question early on. It can be a way to accelerate labeling or correcting some labeling. Again, crap in is crap out. So if you have wrong labels, either because the supervised or the unsupervised labeling or unsupervised learning gave you some clusters that doesn't represent the reality, it can then impact your production model at the end. So it's a mix. What I see within the team is trial and errors. There is no one solution. There is no one method to actually reach close to the goal. And it's either trying different algorithm, trying different ways of labeling, trying to prune your data set. Sometimes, as I said, less data, better quality gets a better model if you have a good representation of your space.
Okay.
Gijs, do you want to add on that, or?
Yeah, I'm just thinking that your labeling, or that's supervised or unsupervised learning, are kind of more derived in, can you label your data, and how much data do you have that needs to be labeled if you want to do labeling algorithm. So I think it's more like a decision that you have to make upfront, saying, okay, I'm going to try this, like you said, try and error, but not, I would not train a model with labeled data and then use unsupervised learning, or vice versa. I would not mix the two, because you might not get the results that you want, and it's not that clean at the end. I would say stick with one method over the other. That's personal preference. I don't know if you agree there.
Yeah.
Okay. This question is, I'm confused about the difference between the machine learning and deep learning and signal processing method, such as denoising. Is deep learning a method to find the best solution for a matrix or equation? If you want to use it or the idea, can I have a quick way?
I think that the best way to explain where deep learning falls in my personal view is, look at this in the circle, and Laurent started as well with putting AI in the middle, and what happens then is deep learning is just one other shell of the onion that you peel off. So it falls inside the domain, and actually machine learning is in between. So I don't know where the question, what was the question exactly in relation to deep learning?
Yes. Because
it is a particular algorithm that is used for a particular question that you want to answer. You have to pick the right family of algorithms to answer a certain question.
I guess the question is more like, what is the difference between a seismic processing or a processing step or doing machine learning? Is machine learning part of processing, or what will be the difference?
I'm not an expert there. I wouldn't know.
So I will give an example, maybe that could answer your question. I would see machine learning as a help in the seismic processing, for example. When you have a cube that is 100 kilometers by 100 kilometers by 10, and you are trying to find a channel, processing that cube is taking a long time if you do it by human. If you try to say, let's train a model that's going to be accurate as me, and pull the channel from that volume, and if you compare cell by cell, you may be 60% accurate. But if you take the approach where I don't care if the model is that wrong, but if it tells me the channel is in that portion of 1 kilometer by 5 kilometer by 2, then my time is dramatically improved, and I can focus myself in that section of 5 by 2 by whatever I said. I think that's where you have the complement of these machine learning models to accelerate your work.
Yeah, it is a tool. It's a tool. Yes, agreed there. It's a tool. And so I was a bit confused with the question there, because you have to pick the right tool for the right job, and machine learning, deep learning can help solving your problem, but it won't be the final answer.
Okay. Yes, since the time is quite over, I would like to ask you all to ask to all the panelists to share the experience about this question. And I mean, what is the greatest impact of AI on the oil and gas industry? So maybe, I mean, in your opinion, one by one, what do you think? How would you answer to this question? So maybe let's start from Mathias.
Yeah, so I'm really working cross industry, so I can only speak for this and now imagine how it can be useful for the oil and gas industry. But AI and machine learning gave us, as Laurent said before, the possibility to interact with software and directly with the real world. So we can perceive now things and and then have a program that takes a decision what to do afterwards, and it can even trigger an action afterwards. And so, so that's a super powerful transformation that's going to happen, because I think there are lots of steps which are done and analyzed by humans at the moment. So I guess we will go into more and more automated systems. And I also think we touched the point of transfer learning. I think data will become, the owners of data will become even more important, because certain models, you can only train them if you have the data available. And also certain companies who are placed to have cross company data available are in a better place to train these models. And yeah, so that's something from my outside perspective that I could imagine. More automation, more important data. Yeah, that's it.
Okay. And then Gijs, do you think?
Yeah, right. I'm kind of long is a relative term, but I'm in the industry for, I think, something like 20 years, and what I have seen is that, and Antoine also kind of pointed out to that, is we already have done machine learning. What I can see in the recent years is that it has been picked up because we have now the capabilities of doing all those calculations on a larger scale and more efficiently than we could do that 10 years ago. Also, people are more connected, things are more connected. So we also have different data streams. And I think that's very exciting to be in this time that you can build those models and show different insights in the data that were not possible, let's say 5-10 years ago.
Yes, okay. And then,
for my part, there is a thing I like to mention is what I call the 3A. So it's accelerate, automate, and assist. And that, for me, that's really where the biggest impact expected with AI on the oil industry. That means that you will first save time, let your experts focus on where their expertness is really valuable, and that you will pick things which are so far in expert niche, and you will make them more democratic, because the first level of study will be doable by automate system that will let these things be used by non-experts. That will help people with different backgrounds work together, maybe in an easier way. So that will be my 3A: accelerate, automate, and assist.
Okay. Thank you. And Milena,
I cannot talk about how it impacted industry. I can talk about academia.
Yes.
In academia, well, it hasn't been really applied a lot, I would say. So I now expect that actually it will have a big impact in the future. I expect it because we have, for example, for seismic data as a marine geophysicist, we have a huge database of different data that were collected at mid-ocean bridges, subduction zones, and they're sitting there, and I'm sure that application of machine learning will help us to tackle some questions, that long-standing questions, and discover some new things by looking at the data in a different way.
Okay, interesting. Great. And I mean, Laurent, how would you answer the question?
Antoine said everything. The 3 A's, I totally relate with that. I agree with that. I actually was going to list only 2, and I forgot the third one. So the 2 that Antoine said was the 80-20. 80% of the work can actually maybe decided by the AI, but it's not going to replace the human. And the 20% is where you can actually concentrate on your added value as a human to make these decisions. And the other was automate where the human can't be. So for example, we are putting AI downhole on our tools. So we start from the Python. We start with model that runs in the cloud, let's say 200-300 megabytes on vision recognitions. And we shrink them, prune them, massage them to bring them to 250 kilobits downhole to run in real time. So that's the automation where the human can't be. You have a potential for AI. And the third A, assist, is exactly what I think as well is a great. So Antoine, great summary.
Great. Yeah, so interesting. I'm sorry, but this was the last question of this Q&A and debate. There were so many questions from the participants, so really thank to all of you. It was very interesting, and yes, so basically I would like to thank to all the panelists for their presence here today, and also thanks to the local chapter Paris and the EAGE student chapter at IFP School for this collaboration. So thank you very much. And I would like, I don't know if Fernando, would you like to add something to that? To close this conference, because we already reached the time. We finished the time today. What do you think?
Yes, to thank all the panelists again, and thank you everyone for coming. I hope you enjoy this moment, and we hope you join us for the next event. Thank you.
Thank you very much. So we can close this virtual conference. Thank you very much, and see you soon. Bye-bye.
Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye, everyone. So, Corentin, I think you can stop recording.
Yep.